All right, new day, new laptop to repair. This time we have an Alienware M17R4. This laptop was sent in to me because he said that the laptop does not show a display. So it's giving like a 27 error code, which points to a bad screen or cable or motherboard, some sort of LCD issue. He said that it doesn't even show a display on the HDMI output. I hate these types of issues because it could be something very simple like a bad cable or bad screen, or it could be something that's pretty complex on the motherboard that's causing this issue. So I haven't looked at this yet. We're gonna look at it together and see if we can get this figured out. All right, let's go ahead and turn this thing on. He said it should turn on. It would just give an error though. Okay, so we did get a backlight on the keyboard temporarily. And now we're getting the backlight again, turn back on. So we are getting a blink code on this Alienware power button. So let's take a look here. 1, 2, 3. And then I can't see the blue. Sometimes that's how it is. So we're getting a 3 red, and then probably 1 blue. And that actually signifies a CMOS reset. So this thing has been sitting around for a while, so it's gonna do a 3-1 as a CMOS reset. We'll turn it back on again. Let's see if we can see this. I may have to do a zoom in here. So we got 1, 2, and then we can't see it. I'm gonna try to cover it up, see if we can get it in the dark. Okay, I'm seeing 2 red, and then the blue, it is blinking blue, but it's very faint, so you're not gonna be able to see that. So a 2.7 error is actually a LCD display failure. So right now we're powered on battery. Let me just plug in our power meter real quick, so that way we can figure out if it's charging the battery and doing all that stuff. We can run a display test on this also. It's another thing to test, but whenever you get a error like this, so basically the way an LCD hooks up, so you have an LCD ribbon cable, you're gonna have a 19 volt power rail usually, or main power rail voltage to the screen. Could be battery voltage or the main charger voltage, but that's gonna be what's powering the backlight, the LEDs. And then you'll have a VDD circuit that actually powers the screen, the electronics and stuff like that. If your backlight circuit's out, the screen will still come on, it will still communicate, but it will just have a faint image. If the VDD circuit or the actual power that powers the circuitry on the screen is not turning on, then you'll have this error right here. So I've dealt with this over the years on this particular model. There is some strange issues that can arise on this M17R4 model with LCD failures. It could be something simple where we just change out the screen that fixes this up, or change the cable. But I've also had some chips fail, some muxing chips, things like that, or even just the VDD power circuit. I do have pretty much every single one of those chips in my chip inventory here, because I've had to replace a lot of that stuff trying to figure out why a board won't display an output. All right, so let's turn this thing back off. I have it off. I'm gonna hold the D key. Hold down the D key when you power it on, and that will put it into display test mode. That's only on Dells, but this will light up the screen in all different colors. That's if the screen is obviously going to work. This will work in pretty much any mode whenever the machine's not even functioning properly. I believe it will work with no RAM in the system even. But we are still getting the blink code here, so machine's still not working. So first thing we're gonna do is, let's open it up. I wanna look at the LCD connector. It could just be a bad LCD connector. We can change that out too. I've also replaced plenty of those. I mean, probably 100 of those at least. Not on this particular model, but, oh, what's this? What's that? Okay. He taped a connector here. I don't know if let's see what this is. This looks like some sort of connector. Okay, all right. I think this is probably the Alienware, the Tron light connector. That's kind of what it looks like. But we'll take a look at that when we open it up. So yeah, let's open up the back of this and take a look inside. We may just have some physical damage. That would be easy to fix. And on this system, it actually could just be a fuse too. I come to think about it. It's not as common, but it could be something simple like a fuse. If someone messed with the LCD screen when the battery is still plugged in, you can blow it out. Usually that's the backlight, not the VDD, but who knows? It could be something simple, it could be something hard. That's why we don't know. All right, and the bottom is off. So The LCD connector is going to be under this back cover, so we'll have to take this off too. We'll take off this cover. This is the Tron light, which is the Tron light's going to be the LED, light up LEDs on the back here, and then there's an Alienware Alien head one is a Tron light also. And that's what I'm thinking that one connector is that he had taped to the back of this. All right, we got the cover off here. Let's get under the microscope and take a closer look at this LCD connector. All right, so here's where the LCD plugs in. But before we mess with this at all, we need to unplug the battery. Always unplug the battery. We do not want any voltage in this system while we're messing with any of the circuitry. The connector looks okay. You can see all the cables in here. This is the data lines, power lines. So I'm just going to pull this out real quick and just see how loose it is. So this side seems very loose. Look at that. So we could just have an LCD connector issue. Now I don't know what would cause it right off the bat, but I'm kind of confused on what the story is. So like, did the laptop work, and then one day it stopped working? Or did it, was it after they took it apart, or did he buy it not working? The story's kind of gray on there, I don't know. All right, let's check these fuses while we're here. So we're gonna put our meter in continuity mode when it beeps. We have a fuse here, so FV, that stands for fuse, and that one's fine. There's another one here. That one's fine. And then the rest of the circuitry is going to be on the other side of the board. Like I said, I've worked on this a lot. Here's the connector they ripped off, it looks like. And this, I think, actually goes to the Tron light that's on the back of the screen. So it'd be the Alienware head. So the LCD connector plugs in. LCD connector plugs in there, and then the Tron light plugs in there, and then that will light that up. Okay, so, you know, before we move too far into trying to figure out, like pulling out boards and doing all that stuff, I can go grab a test screen. We'll just plug it in there real quick, and that way we can verify if it's the screen or the motherboard that's causing an issue. It still could be the connector. I have plugged in screens before and it was like, oh, it works now. It must be the screen, and then it was just the connector had better contact. So here, we can just reseat this one time while we're at it. Let's do that. I really don't like how loose it is. So I'm going to plug it in. Let's go ahead. Okay, I've reseated the connector. Let's see if the screen works now after we've reseated the connector. That would be funny if it's something simple like that. All right, it's going to do a CMOS reset because we unplugged the main battery, so that takes a second. So let's give it some time and we'll be right back. Okay, so we're getting our blink code. No, actually, we're getting the 3.1 blink code, which is a CMOS reset. So I'm going to turn it back off, and then we'll turn it back on and see if we can get the actual display to come on. And I'm going to try one other thing before we go swap the screen out. But, you know, okay, we're getting to 2.7 again. Okay, so what I want to try is I want to try to bend this connector a little bit, make it a little tighter. I know it sounds crazy, because we'll just end up replacing the LCD connector, but I just want to see if this works. Gosh, it's so loose. It's crazy. Like this side for sure. This side's actually kind of tight. That is the data lines. VDD is right here in the middle somewhere. I can't remember where it is. It might be one of these red ones, but I don't think the colors have anything to do with it on this connector. Yeah, and you can't really see the pads too well to kind of see what the power is. Like, these may be power right there, those 3 in a row. And then there's those 3 are ground probably. But anyways, so here's what we're going to do. I'm just going to press down on this and just try to bend some of these pins down a little bit so it's a little tighter when I plug it in. I'm not pressing it too hard. I'm just trying to give it a little bit of pressure. So let's see if it's a little tighter when we plug it in now. Oh yeah, much better. Well, look at that. Still a little loose on that side, but it's definitely tighter. And I'm going to add a little bit more pressure on this side. Okay. Oh yeah, that feels good. Okay. Now again, if this works, then we'll just change out the whole connector and then call it a day. If it doesn't work, we'll go with the screen as the next test. It's going to go through its CMOS reset. Okay, let's reset this again. All right, we'll get that 2-1 again. I'm going to go ahead and go into a display test just for kicks. All right, still getting the error. All right, so let me go grab a test screen. I'll be right back. All right, I got a test screen here, and we can get this connected. And I'm just going to kind of loosely connect it. I'm not like replacing the screen or anything like that. So we have to get in kind of an orientation where we will be able to plug it in and plug in the screen. And since it plugs in the spine, I'll have to do it kind of on its side here. And if you're wondering why I have so many parts, my company specializes only in Dell and Alienware laptops. So I have about 700,000 parts out there in the warehouse. And then I have a test machine for every single laptop that Dell's pretty much ever made. And the reason being is I basically buy out all of Dell's inventory, laptop inventory, and then I'm the one stocking that. And then we test every single part that we sell. So anytime you're buying from us, you know, one thing is it supports the channel, which is great, but it also, what you know you're buying is going to be an OEM part. I put a year warranty on every single part that I sell, and so you don't have to worry about what you're buying being a knockoff or not compatible or things like that. So let's get this connected and see if this is going to work. All right, got it connected. It's kind of dangling around here. I'm just going to set it over here like this. And then I know it's kind of janky here, but we're going to do what we can do. And let me plug it in. And then I know you're like, how am I going to power it on? Well, there's actually a power button on the board right here. So let's see if I can trigger it on. And we'll just look at the power meter and see if it starts pulling current. And then we'll know it came on. And it may actually not turn on because it knows the lid's closed because there's a Hall effect sensor on there. If I unplug this board right here, then it won't know that the thing's closed. So let's do that. Let me unplug the power real quick. So I'm going to unhook this interposer, and the Hall effect sensor's on this board over here. So we're just going to unhook that, and so therefore it doesn't know that the lid's closed or open. And then we should be able to trigger it on with it closed. Okay, so we got that off of there. And plug the power back in. So we have this new LCD screen plugged in. We have the Hall effect sensor turned off, and I'm just going to hit the power button here. We should start pulling current. Nope, still not doing it. So it must think that the lid's still closed. Okay, let's open it up. It's so awkward to get in these positions sometimes. It might be easier just to pull the whole screen off, but I hate having to deal with that. Let me see if I can reposition this, and I'll be right back. All right, here's what I did instead. I grabbed a bare panel and cable. It's a little easier to maneuver than having it still inside its housing, and so I got that hooked up, and that way we can just actually hit the power button. It wasn't allowing me to trigger it on with the lid closed still, so now we got it powering on, and let's see if you can see this. I'll hold this up for you. And we're getting the 3-1 error, I think. Let me turn this back off again. We'll try again. All right. All right, we still get our 2.7. All right, so we've eliminated all that. That's all we needed to do. We just need to figure out if it's an LCD issue or a motherboard issue. And so at this point, we are pointing towards a motherboard issue. The first plan of action is we need to figure out if our VDD is there. The only way we're going to be able to test that is we're going to have to pull this motherboard out. So let's get the motherboard pulled out. All right, and the motherboard is out. I actually like working on this model. It's very easy to get the motherboard in and out. All right, so here's the LCD connector. And so right on the other side is going to be where all of our power circuitry for the LCD is. And so we can check fuses. There's one fuse right there we can check, that FV. That one is on the VDD circuit. This chip right, oh, I just plugged myself. This chip right here is the one that burns out a lot of times when VDD is not working, but that's the fuse that's on VDD. So let's just check it. We're in continuity mode. And that is working, right? So that fuse is not blown. So what we need to do is figure out if we are getting the 3 volts on that VDD line. So let's plug this in. I need a DC jack. And I probably will need a screen plugged into it too, so let's do that at the same time. I'll just use our test screen, and I'm just going to lay it right here, and I will plug in the LCD ribbon cable. Since it's just a bare panel with cable, it gives us a lot more flexibility to move the board around. Okay, LCD's plugged in. Something else that would be nice on this machine, since we're working at it on the bench, would be a power button. So I have a power button here too. I have a DC jack already on my desk right here. I work on these systems a lot, so I'm just going to hook this power button up, and then we have something, a way to trigger it on. There is a power button that's on the board, but it's on the opposite side that where we're going to be working on. So instead of having to move it around, we'll just do this. All right, so we even have an Alienware head, so we can still see if it's erroring out there. So one thing that we're going to try to do is we can actually jump this chip. This heatsink's kind of in my way to do that, but we need to measure to see if we have the 3.3 on that FV line. And then if we don't, we can actually just jump it. The 3.3 is right behind that chip, and so you can actually jump straight across it. I just hope that I'm not going to short out anything. So we will be very cautious when we're working on this. All right, let's plug in the power. I know it seems weird to be working on these on the bench, but you can actually boot a machine just sitting here on the bench. And that makes it a lot easier to work on. So that's why I have all these test devices. Okay, so now we have the power button. Let's make sure it turns on. I'm going to press the power. And pulling current. Okay, perfect. So let's see if we have our voltage here. So on this line, we should have 3.3 on that FV line there, the fuse. And we don't have our 3.3. I'm going to turn off the machine and turn it back on while we're measuring. And back on. And we don't see it spike up at all. Oh wait, it hasn't turned on. Oh, there it goes. So we should get that 3.3 to jump up right there, but we're not. So I have some of these chips. I suspect that that chip may be the issue, but we don't know yet. Let me pull this heatsink off so we can actually get in here and be able to access those that circuitry a lot easier. I'll have to unplug the fans first, because of course they plug in on the opposite side of the board, which drives me crazy. You know, if you want to take a heatsink off, you have to pull the entire motherboard out no matter what. They could make it easy where you can unplug and unscrew all on the same side. All right, when we take this off, we need to not pull up on it. Here you can bend the pipes. You don't want to do that. So I'm going to rock it back and forth until it starts getting loose. There we go. And now we can actually lift up on it. And it's been re-thermal paste recently, actually. So this whole machine has been disassembled in very recently, because this is new thermal paste. You can see it's all moist. Ooh, what a great word. Moist. All right, let me clean this stuff off so it doesn't get all over my desk. Just a little isopropyl alcohol. All right, good enough. Okay, so this is what we're looking at. So this is the VDD circuit. So VDD is the power for the LCD screen. So it powers the circuitry on the LCD itself, okay? And so I believe this is 3.3, and then this is the enable pin, one of these are, and it enables this chip, and then that allows the voltage to come through here, and then goes to this fuse, and then this connects to the LCD connector. That's just based on memory. I'm not 100%, but we're about to figure it out. So I will plug that in, and we'll measure here right now. We have 3.4. So we already have our 3.4 right there, okay? And then this pin right here is 5 volts, so that's powering the chip, and then this must be the enable. So I'm just gonna hold this on here. I'm gonna hit the power button on the motherboard and see if that enable comes on. Because if we're not getting an enable signal, then we have something else going on, but. Okay, board's turning on. It says the board's on, but it's not doing anything, okay. We have voltage here, but we don't have voltage there. Okay, so our next plan of action is we can just jump from here to here, right? So we can bypass this entire chip and just see if it works. And I've done this plenty of times. Let me use some crappy tweezers so I don't ruin them. So I don't have it plugged in right now. So all I'm going to do is I'm going to just jump across there like this. And we're going to have 3 hands. So, so I'll plug this in right now. First thing, can y'all see the screen? Okay, you can see it on the side monitor. Okay, so y'all keep an eye on this screen. So I'm going to go ahead and apply the power to it right now. So remember the 3.4 is going to touch there. And there we go. And then now I'm going to power that on. And we'll see if we actually get the LCD screen to get a picture. Waiting. We can't wait too long because I don't have a heatsink on here. So let me put a thermal pad on the CPU. The problem is I can't do this with the heatsink on because it's in my way. So I try to time it out and I stick my fingers on the CPU and make sure it's not getting too hot. But we're going to just put this thermal pad on the CPU. All right, so we'll put one of these guys on here. And I'll put one of these on the GPU too. The GPU usually doesn't come on right away, so I'm not that worried about it, but it is going through its test process when it comes on after a CMOS reset like this. So we want to be able to give it plenty of time to be able to stay cool while it's booting up. So, all right, so we're going to need to have this tied across the whole time. So let's get that going. We'll turn it on. We'll let it go through its CMOS reset. All right, so we're still getting a 2.7. Okay, so at this point, I'm not happy because this is where the repair starts getting really complicated. I will change this chip out anyway because I have seen these be an issue in the past. Okay, so if we're not getting an enable signal there, then now we're over here in this area. And these are the guys that create the enable signal. I do have a lot of these too. And then if that's not the issue, then we also have this muxing chip here that I've changed out. So, and this power chip, I can't remember what the name of that chip is. But so I've replaced all of these in the past. I cannot, but we don't know what is creating this rabbit hole. And again, it could still be that LCD connector because it was kind of loose. I don't like it. That's what I was saying, like LCD 2.7 errors are like, oh, sometimes easy. You're like, oh, no problem, I just replace the screen or replace the cable or something like that, right? But when you're trying to fix a board with that issue, especially in this machine, because I've ran into a few of them that I never was able to figure it out. So, you know, I'm not 100% on what the cause is at this point, but, you know, we aren't getting that enable signal, and so that means that the chip's not coming on. You know, what we could do is actually put the enable on there and see if the chip turns on, then we know if the chip's good or not. Which I think I remember, how did I do that? I think I short out 2 of these. I can't remember, I worked on this a while ago. So it's something like this, where I just short those 2, and then that turns it on. I'll have to check and see in my notes. Let me check that too while we're at it. We could probably look for any more fuses, but it's an enable that we're looking for at this point. That's fine. I don't see any more fuses around here. Look for FV. Some thermal paste. Boop. All that's GPU stuff. Okay, so the only one that we had is that one fuse there. and we know it's good. And I just did that from using the tweezers. Oh, here's one right here. Yeah, so that's fine. And this is all part of the muxing system, where basically, because you have a CPU and GPU, and so the Intel integrated graphics and then the NVIDIA graphics, they have to be able to use the same ports, basically, or lines, data lines, and so the muxing chip will allow it to, you know, switch back and forth between the two. So I've seen that be an issue in the past, but I don't think that's the issue right now. The Intel is what actually turns on the screen usually, unless someone put it on like NVIDIA only or something like that, which you should never do, by the way. You should never set your BIOS to say only start with the NVIDIA graphics. And because you can just set it in software in Windows, and then that's, you know, in Windows, and you don't have to worry about getting stuck in a situation where your graphics card goes out and your machine never turns on again. You know, one thing that we haven't done, you guys gotta remind me of this. We haven't done our physical inspection. And what's going to end up happening is I'm going to go down this whole rabbit hole, and then I'm going to see some burnt part or something cracked or something. So let's do our physical inspection real quick, and then we'll proceed. All right, so we did look at the LCD connector. It was a little bit loose. We bent it. It seems to be better now. We checked those fuses. That's been ripped off. You know, if someone's taken this thing apart, and I don't know, you know, if that's the cause or not. They might have taken it apart because it's not working, but we want to look around still. So keep an eye out. That's the Tobii eye, so that's going to be like your eye tracking. This is the back of the GPU, I think. And that's the back of the CPU. The machine wouldn't be coming on if it's over there. Okay, so here's the DCN. We have an inductor. These are the main power MOSFETs for the protection circuit that creates the main power rail. The machine wouldn't be working if we had an issue over here. That's the power management chip. That's in charge of charging the battery and stuff like that. That's the LDO, the linear voltage regulator that powers on the EC chip. There's the EC chip right there. That's that extra power button. So this is what starts up the board. We've got some current sense resistors there. We want to keep an eye out for any cracked or ripped off components, so I need to concentrate here. Let's see. We've got those. I don't want to miss. It would be so annoying to miss it. Okay, that's looking good. This is just a daughter board. There's the Wi-Fi cards on there, which is kind of nice. They put it on the daughter board on this model. There's that power button that we're using. And the audio and USB. And then we'll continue over here to the battery charging circuit. That's the battery connector, some inductors. The charging circuitry looks fine. And we know that works anyway, so. Flip this over. This is the 3 and 5 volt power rails. We like to look on the edge of the board too, because if any physical damage is going to happen, it's usually near the edge of the board or near connectors when people are unplugging things. This is still part of the power circuitry. For, I think, because there's another current sense resistor, and I can't remember if this is the main charge circuit or not, but I've had to replace these before, and it's on the main power rail. What's really good about this system is it has lots of power stages for the CPU, so I rarely will ever have to replace one of these MOSFETs on a CPU. Whenever you have these machines that only have like 4 power stages is whenever we have issues, but this one has 7. And even the X series, if you're looking for a good, reliable Alienware, the X series I think has 14 power stages. Something crazy like that. So this is 7 just for the GPU. So the more of those are just basically sharing the power load. That's for the VRAM. There's the VRAM. Okay. So now we circled back. So here is the VDD power circuit. We said that we weren't getting an enable signal, but the chip is getting power. We got the 5 volts. 3.3 is right here, and we jump across, and it didn't actually turn on the screen, which I have had that work before. This area over here I know does create that enable line, but we're going to have to kind of investigate a little bit more on that. There's the power circuits. Okay, so there's the chipset. Chipset could have something to do with this. You never know. What else we got? This is flux is crazy. It looks rusty almost. All right, so now we're over to the. Sorry, that was the CPU. I don't know why I said that GPU. This is the GPU. So the GPU has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then these are going to be for the VRAM. So, you know, scratch what I said earlier. So this is for the RAM that's on the board. So that's onboard memory. And then this is the GPU. And we have all these power stages for the GPU, and then these are for the VRAM, which is right here. And there's that other side of that daughter board. Did anyone see anything? I didn't see anything. But I was also talking and distracted. So I feel like this is how I miss things, is because I'm sitting here talking to you guys. We gotta look underneath this too while we're at it. Okay, nothing cracked, nothing burnt. Well, we circled back around, so let me think about this. I got to pull up my notes to see if I remember how all this is wired, and then we can figure out what the next plan of action is, and I'll explain kind of my thought process on it. You know, because we're missing the enable line. Now, are we missing it because it's there's a problem with one of the circuits over here? Because the thing about enable is sometimes you can just enable something and then boom, now you have that power rail and then now everything just works. But if whatever's enabling that has more logic behind it, where it says, okay, let's enable this and enable that and enable that, and we're only getting one of those enables because we're forcing it and the other ones aren't, then it still won't work. And that's kind of what I've seen happen on this machine. There has been a few of these that had this exact issue, and I was never able to figure it out. And I must have changed every single chip that was in that area, because I'm determined to fix these things. I hate whenever I can't figure something out. And if I spend a little extra time on one machine, then it makes it easier to fix something else in the future. So, but let me pull up my notes for this, and I'll be right back. All right, so I took a quick look at my notes. So it was kind of what I remember. So yes, this pin right here is the enable, and it actually ties to this chip, and there's a little comparator here, and so this is like a and/or gate. And so when these two things are high, then there's 3 volt coming in here, and then that this ties to the direct enable pin. You can actually just short across here, and then that will put 3 volts on the enable, which will turn this chip on, which will allow voltage to flow. So let's just check to see if the chip's working first. So let me plug in the power. So the power's plugged in. I'm gonna put my probe on here. So right now we're getting nothing. I'm gonna turn on the laptop. I got the motherboard turned on. We're still measuring at that pin, we got nothing. So now we're gonna short these two out, and this will send the enable signal. And now we are getting the 3.4. So we know for sure that that chip's working fine, right? We just send an enable there, and then that allows the voltage to flow through. So that chip's not bad. We know the fuse is working. Let me hook the screen back up, and then we'll go ahead and enable it and see if we can get the screen to come on. All right, we got the screen reconnected. So just keep an eye down here, right here. And then I'm gonna plug in, I got the power plugged in. I'm gonna short these two out to enable that VDD. And then now I'm gonna turn the actual board on. So the board should be powering on. We just wanna see if the screen flashes on for a second or does anything. All right, and we're still getting a 2.7 error. All right, so unfortunately, we have to slowly work our way back here, right? So we know that we're not getting an enable. We know that we have to have these two things high or low. I don't know which direction it's supposed to be, but these two lines right here are supposed to enable this 3 volts to get over here. Well, we're not getting a signal here. Well, where do these things go? Guess what? They go to the muxing chip here. So I have no real way of testing that, but we're going to go ahead and change this out, and I want to change this one out. I know that they kind of work together as part of the power circuit, and I believe I have both of these, and so I think the best plan of action would be just to change both of those out since we have them, and then we'll just go from there. So let me go ahead and grab those and get that set up. All right, let's see which one we need. This one is the mux. So we can grab one of these. And then, what's this other one? This one might be the one next to it. Let me see. Yeah, okay, so here are the 2 chips that we need to change out. And then we'll just change them out and we'll see. I don't know. All right, so I'll remove these first and then we'll get the new ones installed. Okay, we got both of those removed. While it's hot, we're going to put some fresh solder on it. Solder, as I'm supposed to pronounce that L, which I'm not very good at pronouncing the L. I like to say solder, but solder. I will do my best to appease the crowd. All right, just going to add some fresh stuff here. I'm going to take it back off and then we'll do it again. Okay, very nice and clean. New solder on there. Solder. Let's grab our new mux chip. Okay, which way does it go, you ask? There's the dot. And there's the mark on our board. Dell's really good at marking the boards. I like it. So it's on that side. So the same with this. There's a mark there. That's going to be pin 1's on that side. That's pin 1 right there. So we'll line that up like that, like so. Okay. And we're going to hit it with a soldering iron after that, but let's just get these in place. So again, pin 1 on the side. Okay. So we'll just reflux it, and then I'm going to just hit it with a soldering iron, and that will make sure everything has a good connection. Good. Okay. All right, we got the mux chip and the other power chip replaced. You know, if these don't work, I still don't know what the next plan of action is, because it starts getting kind of rabbit hole-ish on this, and I could sit here and spend many, many hours on this. I may end up changing out the LCD connector, actually. That might be the next one to do, just because I wanted to have a really good connection, and I did notice it being loose. All right, got the LCD hooked back up. Let's go ahead and start measuring over here. We're in voltage mode, and we're just going to measure right here. I'm going to plug in the power. And we have 3.4 there. Okay, so now let's hit the power button. And we're still not getting our 3.4. Nope. Still not getting our 3.4 on that power rail. Let me trigger it on real quick. Got a 3.4. Let me reset this real quick. All right, so we've replaced the main chips that actually handle sending that voltage over there. You know, and like I said, it's kind of a rabbit hole type of situation. Here, let me measure right here. I did not do that last time. Remember, because this is a comparator chip, so it's going to be like an AND OR gate. And I want to see what signals we're getting on here, because this actually goes to here. I have a lot of these chips to change out too. In the past, I've tried changing all of these out to see if that fixes the issue, and it didn't fix the issue either, but I just want to see what signals we're getting over here. So this one comes and goes over there. This one goes in the board somewhere. This one I think goes straight to the MUX chip. This one comes here, then comes over here. I mean, there's a lot of stuff going on, and it could be even like one of the pins on the LCD connector. It's trying to detect that, but then if it's not getting a good connection, then it basically says LCD is not plugged in, so don't turn on the VDD. It could be something like that. Yeah, I think I may want to replace the LCD connector next. You can kind of see that it is bent a little bit. So if you like pay attention, on these edges, see how that's bent up? And what you're looking for is kind of a hump. And you can definitely see a hump here in the center. This is all part of the VDD area. This is the main power area. We could try bending this down a little bit more again. Yeah, this whole area in the middle is kind of humped up. So we may not be getting good connection here. So, but just replacing the connector with a new one usually fixes that issue. So I'm just bending these down a little bit. But you see even the center's kind of humped up. And I don't think it's an issue of a actual loose pin here. Nope. We could try just applying pressure to it while we're turning it on. All right, I have the power plugged in. There's our LCD connector right there. So I'm just going to press down right here. And we're going to power it on again. All right, so I have the machine on. And we're still getting the 2.7. All right, I went ahead and just reinstalled the motherboard. Trying to figure out, I want to see what is causing this issue. I'm starting to believe that it might be something more catastrophic, like a chipset or something like that, because we're not getting that enable signal when we need it to turn that on. And I went back to the original screen too, since we know that our test screen is doing the same thing. So let's see if it's going to work when it's reinstalled in the machine completely. All right, we're still getting the error here. Yeah, so at this point, because I mean, there's a lot of parts that kind of talk to each other in order to turn an LCD screen on, and we have the EC chip, which turns on the machine. We have the PCH or chipset is what directly tells the actual screen to come on. And if we're not getting that signal there, then we may end up having an issue there. And then we have those MUX chips and things. That's why I wanted to make sure we changed out all of those, because those chips also are, telling it to come on, but the PCH is actually talking straight to that MUX chip. So one last ditch effort I want to do before I kind of just call it and say that's a chipset issue is we'll go ahead and change out that LCD connector, since I have them and we knew that it was a little bit loose and we're sitting there bending it. Who knows, this could fix the issue. It is complicated. I've done enough of them, so it doesn't take too long. So let's go ahead and get that LCD connector replaced, and then we can kind of wrap this one up. All right, and for those who have not changed out an LCD connector, which I would assume is most of you guys, so we have 40 pins. This is a standard 40 pin EDP connector, or LVDS, sometimes they call it that. And so to get this off, I don't really care about saving this one, so we can use high heat and just heat it right off of there. What we don't want is to rip a single pad. So that's our biggest concern when we're taking this off, because we do not want to rip any of these pads of these 40 pins here. So to get it off, I usually will flux it. So we'll add plenty of flux here. We're going to add fresh solder, and then that will allow the pins to actually melt at a lower temperature, and then we'll heat it up and we'll just pull it right off with some tweezers, and it should just fall right off. We'll use high heat, but it will destroy the connector. When we put the new one on, I'll show you how we do it so we don't damage anything. All right, so I'm going to flood the connector here with some fresh solder, because we're not trying to save this. And don't forget to flood the ground points, because that's actually what's securing it. So this solder melts at about 183 degrees, which will make it a lot easier to get this off. Now I'm going to be we're using 450 at 450 degrees C, 60% air. And we just want to see it start lifting up, and then we will help it kind of walk its way off of here. So first I want to get this edge up here, good. We got that edge up, and then we're going to work our way across. And I'm just lifting slowly. Not much pressure is being added here. And then there it goes, it just flew right off. And that's what we were looking for. All right, so we took the connector off, we didn't save it though, right? If you wanted to take this off and save it, it's a totally different process, so don't do that. There you go. So we have to clean up these pins. And when we're cleaning these up, we still have to be careful, because these are going to be very delicate, and if you start just rubbing really hard with your soldering iron, you can actually pull up a pad too. So I'm just going to pick up some of this solder like that. We want no solder on these when we're done. So I'm going to take some solder wick and just lightly, when I'm not applying a lot of pressure, just lightly drag it across here. Perfect. And what we're looking for is to not have any solder on these pads. Okay. Perfect. Now we'll wipe this off. All right, so now we want plenty of flux on here. And a new connector. All right, so here's some new connectors. If you want to know the number on this, I ordered these from Mouser, and here's the part number. Okay. If you go on eBay or something, they're going to sell these for like 10 or 20 bucks each, and I think they are only a few bucks. I think maybe they might be $4 or something like that. But all right, so we have the new one here, and we're just going to set it in place. You remember, you want to have all that flux under there already. And it's crucial to get good positioning right off the bat. And so what I'm looking at when I'm trying to position this is I'm looking at these pins on the sides here, and then this line in the front. So you can see that I'm lined up with the line. It tells you how far back to go, which is nice. And so I line up where I kind of can see the line that way, and then I line up where the pins on these pads are lining up. Here, I can zoom in closer for you to see. And so the first things that we're going to solder is we're going to solder these end pads, that one there, and then that one there. And then we're going to do these next, and then we'll do one pin at a time. So let's get this tacked in place right here. And so to do this, I'm just going to put a little bit of solder on my iron, like that. We'll put some air on. Ooh. And I'm just going to touch it. Need a little bit more. Now we don't want to flood it, because then it will suck solder up into the connector itself, which we don't want. So we just want to get just enough There we go. So that's in place. And now that we have just one corner tacked, what I'm looking at is I want to make sure that we have all this is still lined up straight. This line's good here. We're going to go across, and over here looks good too. So once we're happy with the positioning of that one side, then we can do the other side. I'm going to hold this down, hit it. Let me add just a little bit more solder there. So in general, you don't want to put solder on your iron and then put it there, but because I have to hold it down at the same time, I'm going to do that. But I have extra flux there already. Okay. All right, I'm happy with that. This one has just a little too much, but it's okay. All right, so let me get in position because we have to do all the other side, and I have to get the pins facing the right direction here. Okay, I'm actually going to add a little bit more flux. Yeah, look at all that. All right, we're going to put just a tiny bit on here, and we still need to apply pressure when we're doing this, or else we're going to not have a good connection. So I'm going to get on there, and I'm going to touch the pad and then the pin and let it suck up onto it. There we go. Okay, so we're going to hit this one now. Hit that one. I'm only doing one pin at a time. If you feel tempted to kind of slide the soldering iron across it, you're going to end up connecting multiple pins together, and you don't want to do that. And once you get low on solder, you just put a little bit more on your soldering iron. Gosh, I need to clean this again. You know, when the solder just cooks on there for a while and ends up making it dirty. Okay. So the idea is you heat the pad and then the pin will heat up with it. You want to transfer the solder onto the pin. I still don't have enough solder on my tip here. Having issues with my tip here. I might need to switch tips. I don't know what's going on with this one, but it's not working right. Let me switch tips real quick. I changed my soldering tip out, so this one should work a little bit better. I just wasn't able to get that solder transferred over, and the issue, a lot of the issue is because I'm putting it on there and then touching the point, but this should work good. I hate doing it this method anyway, but sometimes it's a pain. Okay, so yeah, we're definitely getting it to transfer now. There we go, yeah. That's what I was looking for. So we're just gonna do one pin at a time, working our way down. You always want to apply the pressure, because what I found is that sometimes it will be lifted up, and then after you've soldered all these pins, it's kind of hard to get it to set down. Okay, and this last one right there, perfect. I'm going to reflow this one now that we have this other tip on there. Perfect. And we'll do this one. Although the other tip must be the end of its days. All right, everything looks good there. I'm going to clean it up. I'm going to clean it up real quick, and then we'll take a look closely and check every single pin. Nice and clean. All right, so the last step whenever you solder something like this is you need to check that every pin is connected. So we're just going to tap on each one. Good, good. All right. and clean it a little bit more with a toothbrush. A lot of that flux likes to stay underneath the connector, so. Okay, so we have a new LCD connector installed. So we've already changed out the MUX chip, the power, the VDD, we've verified that. And so this is kind of the last ditch effort, because what's going to end up happening is that it just means that the chipset's actually not sending the signal, and the chipset's the issue. So let's go ahead and put it back together. And cross our fingers, right? All right, we got the motherboard installed. Let me see how tight this connector is now. All right, you ready? Oh, wow, very tight. Okay, well, what do you guys think? I don't know, actually. I hope it works. I hope it works. You ready? Got the keyboard backlight for a second. It's powering on. And was that an LCD failure? It's doing it right here too. 1, 2, 3. Oh, that's actually CMOS reset. Okay. Let's try it again. One, 2, and 7. Yeah, so physically, I don't think it's going to be one of these chips. It's not the screen, it's not the LCD ribbon cable, it's not the LCD connector, it's not the VDD chip, it's not the MUX chip, it's not the other power chip on the MUX area. We're just not getting that enable signal, which is going to be coming from the PCH, which is the chipset, and unfortunately, I can't get this to get an external monitor either. I already hooked it up to an external monitor off camera and tried that for, I don't know, 20 minutes or something. Tried it with the screen attached, without the screen attached. No matter what, you can't get it to post. It just gives you that error. So there's some sort of flaw in the communication between either the GPU video on like the NVIDIA or the Intel integrated graphics and the chipset. So basically on a HDMI external display, that's actually coming straight from the NVIDIA chip. And then whenever you turn on the machine, it should be on just a regular LCD, it should be coming from the Intel integrated. And since neither one of those things are working, you're not getting either or. It's probably just a dead chipset, and it's unfortunate. So wasn't able to fix this one. Love to know your thoughts, and this will just be a motherboard replacement. And thanks for watching.
I couldn't save this laptop.